Here is a combined summary of the 2 pages from the research paper. This research proposes a novel motion prediction pipeline for firefighters squads in indoor search and rescue. The pipeline combines an optimal graph-based planning approach with a modification of the headed social force model, HSFM. The graph-based planning approach generates squad paths per room, considering restricted and unrestricted vision, and adapts locally without global replanning. The HSFM simulates individual agents' motion, incorporating inter- and intra-squad behavior. The HSFM, first introduced by Farina et al., models human behavior by considering locomotion, velocity, and social forces. The model consists of 4 equations, defining the agent's pose, velocity, and mass, as well as the social forces acting on the agent. These forces include agent-agent and agent-border interactions, as well as the agent's motivation to reach the goal. In the context of firefighting, different tactics are applied depending on the room size and visual conditions. This work focuses on the attack stage, where firefighters explore indoor disaster environments, commonly with respiratory protection. 4 tactics are applied: free traversal, wall search, right-hand rule and left-hand rule, diving search, and tree search. The wall search tactic is particularly important, as it is used in small to medium-sized rooms, common in civil buildings. To parameterize the models, a novel dataset was generated from real footage and thermal recordings of firefighters' motion. The dataset includes velocities, distances, and other parameters, which are essential for modeling firefighters' behavior. Although the sample size is limited, the dataset provides vital reference values for indoor search and rescue. The prediction framework consists of 2 stages. First, waypoints are generated by optimal path planning per room and squad, using a graph-based approach. The graph is constructed from a building plan, which is usually available, and is segmented into individual rooms and their connecting doorways. 3 graph construction methods are used: medial axis, visibility roadmap, and pseudorandom sampling. The waypoints are then used in the HSFM to generate agent individual trajectories, allowing for the prediction of single agents' motion as well as individual agents in a single or multiple squads. The proposed motion prediction pipeline for search and rescue (SAR) applications combines optimal path planning with a modified Helbing social force model, HSFM. This approach utilizes 3 specialized types of graphs to model the tactics applied by firefighters in SAR scenarios, while the HSFM generates agent individual motion trajectories. To allow traversal closer to borders, the agent-border interaction has been modified by introducing a soft contact model. The models are configured with a novel dataset and tested on various scenarios, demonstrating feasibility in generating trajectories for SAR tasks. The computational times for single squad traversal are low, making the method suitable for deployment in collaborative rescue applications. The research paper discusses various aspects of pedestrian dynamics, social force models, and their applications in emergency response scenarios. It begins by referencing key works in the field, including the social force model by Helbing and Molnar, and the headed social force model by Farina et al. The paper then delves into the importance of considering social grouping in pedestrian motion prediction, citing works by Yamaguchi et al. And Rudenko et al. The authors emphasize the need for joint long-term prediction of human motion under social grouping constraints. They also highlight the significance of communication concepts in emergency response, such as the emergency messenger. The paper concludes by discussing the application of algorithms like the Voronoi diagram visibility graph potential field compound algorithm for robot path planning, as well as the use of Monte Carlo methods for complex system simulations. Throughout, the authors stress the importance of integrating social dynamics and communication aspects into emergency response strategies.